So, all right, we are looking at solving exponential equations and specifically with the same base, which is a special condition. And sometimes, depending on the exponent laws, you may or may not know every single one of them at this point. You should. Good idea. So I'll have some other techniques that you can use if when you look at these or the homework and it doesn't immediately go, ooh, I know how to do that, then you can try one of the other techniques. And I would encourage all of you, I do encourage all of you, even if you know how to do this, come back and use those other techniques. Just get a feel for it. Maybe you like one of those better than this and you consistently practice that. Suggestion, because there are multiple solving techniques, that introduces a brand new way of double checking. Same double checking before, x equals a number, plug it back into the original equation, compare the left side to the right side. If they're the same, you're good. But you could also solve it with a different technique and still have to type a little bit in the calculator to confirm. All right, let's just dive into it. So here is our first example. And pause for a moment. Do you see the connection? Can you take the exponential on the left and the exponential on the right and use whatever exponent laws to turn them both into exactly the same base to a power and then move forward in solving? If you can see how to do that, and sometimes it's just a matter of playing around on the calculator a little bit. And typically, not always, but a lot of times, you need to change both of the bases on the left and the right into a number to a power. And sometimes that's where the problem is. You might have an idea for one of them, 4 is 2 squared, but how do you turn 1 over 8 into 2? Well, if you make it that far, then you can just go to the calculator and go 2 to a power, 2 to a power, 2 to a power. Now, it is helpful to know that because the base on the right side is a fraction, it's going to be 2 to a negative power, 2 to a negative power, like that. So knowing some of those rules is very helpful. All right, let's just proceed. So as I suggested, the base should be 2, and 2 squared is 4, and 2 to the negative 3 is the fraction 1 over 8. The other rule is that when you raise a power to a power, they are multiplied together, as you can see in this step as well. So my scratch work, just for the thinking bit, like I suggested before, is knowing that you got a negative exponent on the right, and if you can recognize the common base left and right is 2, then you can go to your calculator and just push the buttons a little bit and figure out what that power is. The rest of it, when the bases are the same, the exponents are the same. And this one turns into a linear equation. Solve the way you have by undoing what is happening on the left and the right there. And as I said before, if you plug that number back into the left side, type it in your calculator, what does it equal? Plug it into the right side, type it in your calculator, what does that equal? And that looks pretty good to me. I mean, not technically an exact value, but still, I doubt that that decimal that's not on the screen is changing that value there. So, but again, we'll learn some other techniques of solving, and you can use them instead. I wish you would practice them, whether you got this or not. All right, next example, kind of similar to this. It's not always going to be, oh, this one is squared and that one is like that. But the teachers do try to keep these not crazy, insane, you know. Alrighty, so common base is 3. Change those guys. This one didn't have an x on both sides in the exponent. Doesn't matter. Same idea. So once you have the basis the same, the exponents are the same, solve it, double check.